So the denominator should equal -6. So we'll do some cross multiplying. So we'll get 2 times the y minus 5 equals -6 times 5. So that's what I've got there, -30. You could expand the brackets, but I decided to divide both sides by the coefficient of the bracket, 2. Made it a bit easier. And I got down to y equals -10. So this will tell me that the point A is -3, -10. And that would give me a line that passes through A and B, perpendicular to that original line, 2x plus 5, y equals 12. Quite tricky. Another trick to have up your sleeve is that the gradient of line can also be found from its angle of inclination, and that's the angle it makes with the positive x-axis. So hopefully you agree with me that gradient is rise over run. So I probably should write rise there, and rather than change in x, you're probably more familiar with run at the bottom there. So add those in. Now hopefully you agree with me that this angle theta will be the same as this angle, but really they should have drawn a big triangle here, so I might fix that up. It's not the best diagram. So let's imagine for this line we have rise over run, and it will make this angle with the x-axis, the positive x-axis. Okay, so this sort of right direction. Now if I went tan theta, I would get opposite over adjacent, rise over run, which is the gradient. So I can say tan theta also gives me the gradient. So you might see some questions that pop in and say the angle of inclination is 45 degrees. Well, if you go tan 45, you get 1, and that's also the gradient of the line. So keep that little trick, but we'll definitely do more on that later in trigonometry. A quick little reminder of 2 formulas that you've used in the past. The distance formula, which is sort of based on Pythagoras, so x2 minus x1 all squared plus y2 minus y1 all squared. They could turn up in these problems. They're sort of assumed knowledge. The midpoint formula, well, you can use the formula, or I just average the x values, so add them up, divide by 2, and average the y values, add them up, divide by 2, and I've got the midpoint of 2 points. So in example 1, we've got an interval joining A and B, and this is the diameter of a circle. So if the length from A to B would be the length of the diameter. The question asks for the length of the radius. So you're going to need to find the length of the diameter and halve it. So have a go at using the distance formula to get the length of the diameter, leave it in surd form, and then halve it to get the radius. And let's see if we get the same answer. Okay, so we've got x2, so -7, take away 3, all squared, and then y2, so 5, take away -1, so +1, all squared. And if the order's different, as long as the 5's with the 1 and the -7's with the 3, you'll be fine. So what I like to do is work out what's under the square root first. So that's 136. And then if we can break that down, we should. So I'm going to pause and have a think what square number goes into it. I'm definitely thinking 4 does. That's a bit gross. Hopefully 16 doesn't. I'm going to have to go get my calculator. Okay, I'm back. So 16 didn't, so 4 was the biggest square number, and that gave me 2 root 34. So that's the length of the diameter. So the radius is half of that. So I would say the length of the radius is root 34. And we'll write units just to finish it off. Now example 2, I think this is quite an interesting question actually, and we're going to start with a sketch. So we've got the points A, B, C, and we're going to plot them, and we're going to have to find the point D so that ABCD is a parallelogram. And we're going to do it the easy way, okay? You could definitely do equations of lines and perpendicular and distance and all that sort of stuff, but we're going to do it very visually.